Hi everyone. So today we're going to be talking about logic, which is the start of chapter 6 in your textbook, I believe. So there's already a handout that's in D2L and that should have been emailed to you by the time that you see this video. And this video is meant to be a supplement to that handout. Now, logic is the study of statements. And really, at the very central heart of mathematics, this is what we study in math. Most people think that mathematics is the study of numbers or of functions or operations of numbers, but that's really not, as a mathematician, what we do at all. What we really do is study statements, and very often, of course, these statements involve numbers or operations between numbers, but they're not the central focus. It's the statements that are the focus. So a statement is a sentence that is either true or false. And so some examples of statements would be something like 2 is greater than 1, 3 plus 2 is equal to 6, and x squared is bigger than 5. So here are some examples of statements that use numbers that we might be used to. So some of these things, 2 greater than 1, for example, is a true statement. 3 plus 2 equals 6 is a false statement. And x squared is greater than 5 is either a statement that's either true or false depending on what x is. But the point is that for any value x, it would either be true or it would be false, that it couldn't possibly be both or neither in any given circumstance. So a statement is any sort of sentence that is either true or false. And like I mentioned, we don't have to limit ourselves to just statements about numbers. Billings is a city in Montana. Uh, is certainly a statement and it is certainly takes on the value of either true or false. Now, what we're going to do in this section, of course, is we're going to be studying statements, operations on statements, and compositions of statements, which are very similar to composition and operations on numbers. So let's say, as an analog, here we have numbers and here we have statements. So in the typical um, math class, you might have something like that deals with numbers like x plus y. And what is this equal to? Well, it depends on the value of x and the value of y, right? So x is a number, y is a number, x plus y is also a number. So what we mean by an operational statement is we would have a statement P and then some operation and then some number Q, and that's going to have some value as well. But instead of being numbers, P and Q and this thing are going to take on the value true or false, right? The numbers here could have infinitely many values. There's infinitely many values that could be here. But depending on our operations here, P could either be true or false, Q could either be true or false, and the resulting thing is then either true or false. All right, so let's suppose P is the statement, I will eat breakfast today. The first example of an operation is the not operation, which we describe as not P. So not P is the statement that is true whenever P is false and false whenever P is true. And so in our example here, if P is the statement, I will eat breakfast today, then not P should naturally be what? What do you think it is? Well, you've been paying attention to everything I've been saying here, right? And so my stepson is behind the camera here. So, right. So P is a sentence that says you'll eat breakfast today. So what's not that? What does not P mean then?
Peace. So it's not P?
Yeah, so what is that then? If P is eating breakfast today, then what is P not happening?
Not eating breakfast?
Exactly. I will not eat breakfast today. Right? If you're just looking for a statement that's true whenever P is false and false whenever P is true. So if P is a statement that's true when you eat breakfast, then the negation or the not of that statement is a statement that's exactly the opposite of that. So not eating breakfast today. If you eat breakfast, then P is true and not P is false. If you don't eat breakfast, then P is false but not P is true. So that's exactly the circumstances that determine that. And what we would describe as a sort of table to sort of illustrate that is something called a truth table. So what we would say here is for both values of P, that it's either true or false, the not P's values have to be false or true. All right. I'm going to add a second operation to this whole mess, or a second statement. Sorry, we're going to add one more or two more operations. But Q I'll add to this is I will eat lunch today. And now the second operation I'm adding in is the operation and. Now, and is a statement. We express and as with this caret symbol here, and we say P and Q is a statement that is only true if both P and Q are true. All right. So, Byron,
Yeah.
if P is I will eat breakfast today,
And I.
and Q is I will eat lunch today, then what would P and Q be?
I will eat breakfast today and I will eat lunch today if
Or
both if you do both of those.
just right. So it's just a statement, right?
Yeah.
You don't need to include the description as part of the statement. So it really is I will eat breakfast and I will eat lunch today. There's a lot of ways you can phrase the same statement. In the same way that in algebra, there's a lot of ways you can express the same thing, right? So like 2 times x plus 3 is 2x plus 6, for example. And so when we make these compound sentences, we're not so concerned about the exact wording as we are as just expressing a statement that is true only if P and Q are true. So let's say you do say this sentence. You say, I will eat breakfast and I will eat lunch today. Well, that's only true if you eat both breakfast and lunch. If you decide to skip one of these, then you're not telling the truth anymore. If you skip both, you're definitely not telling the truth anymore. So the truth table for something like this is a little more complex because there are 2 values for P and 2 values for Q. And so there's 4 combinations in total. They're both true, P is true and Q is false, P is false and Q is true, they're both false. And in this case, P and Q, it's true when P and Q are both true, and false otherwise. And so in the example of our lunch scenario or a meal scenario, what we'd say is, all right, if you make this statement, I will eat breakfast and I will eat lunch. If you end up eating both, you told the truth. Any other circumstances means that you lied. Right? So that statement is true if you do both, false otherwise. Then a sort of analog to and, I'm going to keep this because we'll still use that as our example, but is or. Or is a lot more forgiving than and. Write or P or R with this V-like wedge here, and then we say P or R is a statement that is true if, P or Q, if either P or Q or both are true. So if P is true, then it's true. If Q is true, then they're true. And if they're both true, it's definitely true. So again, if P is I will eat breakfast today and Q is I will eat lunch today, then P or Q, what would be a good statement for P or Q?
I will eat either breakfast or lunch today.
Good. I will eat either breakfast or lunch today. And so let's write out the truth table for that. So P, Q, P or Q, we have our same 4 combinations. So I'll eat either breakfast or lunch today. If you ate them both, is that true?
True.
If you ate breakfast and skipped lunch,
True.
is that true? Yep. If you skip breakfast but ate lunch,
True.
If you skip breakfast and lunch,
False.
false. All right. So, given the statements P and Q, we can compose them with ands, we can compose them with ors, and we can also apply nots to either statement. So, let me test Byron here a little with, we'll start with a statement here, maybe. I will skip breakfast and have lunch. All right. What would using P and Q and the operations we have described so far today, what would make up this sentence here?
We would definitely be using and, of course, because
Okay.
in there, P would be I will skip breakfast.
Well, we're stuck with these P's and Q's.
Yeah.
So instead of I'll skip breakfast, what could we use? Instead of changing P, could we express skipping breakfast in terms of P?
Without changing like the wording of that.
Yes.
I was about to say I will not eat
All right. So
breakfast.
right,
And then,
P is eating breakfast, so not P is skipping breakfast, right?
mhm.
And you're gonna have lunch.
So I will have lunch,
Right.
of course. So
It does
Yeah.
seem like just Q is fine,
yeah,
right? So if P is having breakfast, Q is having lunch, not having breakfast and having lunch is not P, not breakfast, and Q, lunch. So let's see when this thing is true or false. As you become more comfortable with these logical propositions, you don't have to write out all these intermediary steps. But it helps for now while we're still getting used to this. So here we have P and Q and other four combinations again. Right? Not P is false when P is true, right? And it's true when P is false. Now, false and true is false, right? The and statement is only true when both things are true. So false and false is
false.
True and true is
True.
And false or true and false is
False.
false. Right? So here we have a statement that's only true in this row and false in every other row. Now let's see if that makes sense just intuitively. If you say I will skip breakfast and have lunch, you should definitely skip breakfast. You should definitely have lunch. If you don't have lunch, you're false. If you eat breakfast, you're false because you said you would skip breakfast. So the only circumstance under which this statement could be true is exactly when you've skipped breakfast and had lunch like you said you would, right? So when we work through the logic and when we look through this example, they should coincide. They should both make sense. Now, at a certain point, we will be working with just these statements independent of some representation. In the same way, in algebra, we can work with variables and numbers without having some concrete thing attached to them. But if it helps you get used to it, whenever you see some collection of statements, it is certainly helpful to make up values for P and Q, make up statements for these things, and then see if what you produced makes sense in relation to that. Okay, then we will do one last sort of example for this video. And that is, we're just going to introduce a third variable, R. Certainly, we could say that R is I will eat dinner or something like that. But again, at this point, we should be moving past the need to attach a concrete value to our variables. So let's look at what is the truth table for not P or Q and R. So P could be two things, Q could be two things, our new thing R could be two things, so that's 8 possible combinations. Half the time P is true, half the time P is false. Half the time Q is true, half the time Q is false, half the time R is true, half the time R is false, and if you follow this pattern down, we see we have every possible combination of true and false between P, Q, and R. So, let's start. Not P is going to be false and then true. Right? So false, 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 true, 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 true. All right. Q and R. Let's take a look at that. Well, Q and R is only true when both Q and R are true. So true here, false, 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 true here, false, false, false. Right? So then we'll write false in for all of these. So not P or Q and R. We will look at not P, we will look at Q and R, and it's true whenever either of them are true. So because this one's true, true, they're both false, so false, they're both false, so false, they're both false, so false. They're both true, so true, this one's true, this one's true, this one's true. So this would be the truth table for not P or Q and R. So in the context of our meal examples, we could say that this is, I better make sure I'm still in the range. Okay, I think I'm still in there. I'm either going to skip breakfast or I'm going to have lunch and dinner, right? So if you have lunch and dinner, that's true, right? So if you have lunch and dinner, that's true. And if you skip breakfast, that's also true, right? But let's say you eat breakfast and you eat lunch, but you don't have dinner. Well, you ate breakfast, so that's not true, right? You ate lunch, but you didn't have dinner, so that's not true either, right? These are both false. You didn't skip breakfast, you didn't have both lunch and dinner, so your statement ultimately was false. All right, so I hope this was instructive and informative, and that this will help you with your studies. Again, if you have any questions, I'm happy to address them in video form if you want, or you can always send me emails in the usual way and I'll send that back to you. Byron, could you kill the recording?
Yep.
Thank you very much.